Hey, it's T. I'm one of the geniuses at AskZylor. So let's just get started with the live session. So the first one is dealing with grade 9 math. It's dealing with an area question. So it's telling us the dimensions of a side of a bridge are shown in the diagram below. The arches are semicircular with the same radius. So we're asked to determine the area of the side of the bridge shown. So the shaded area over here, right, and show the work. So in order to find the area, it looks like a rectangle, right? So what we could do is find the total area of this rectangle and subtract the area of these semicircles, right? So the total area equals the area of the rectangle minus the area of the two semicircles. Okay, so let's go ahead and find the area for the rectangle. That is pretty easy. It's just 20 meters is my length. My width is 8 meters. Right, so I'm just going to do 20 meters times 8 meters to give me 160 meters as squared as my area of my rectangle. Now we need to find the areas of the two semicircles. Right, so we know the area of a circle, right? It's going to be pi r squared. So we need half of that to be one semicircle, but we have two semicircles, right? So in total we make up one full circle. So we just have pi r squared for the two semicircles. So we need the radius though, right? So they haven't given us the radius, but we could figure that out because they've given us these dimensions, right? So the total distance is 20 meters. But they've given us 3, 2, and 3, so we can find the missing, right? So the radius, this is one diameter, this is one diameter, right? So in total we have 4 radius between the missing dimensions. So we can do that by finding 4 radius is equal to 20 minus 3 minus 2 minus 3, right? So my 4 radius would end up being 20 minus 8. So this would give me 12, so my radius would end up being 3. So I found my radius, so I can just plug it into my circle equation, radius 3 squared, right? So my area for my total is the area for my rectangle minus the area for my semicircles, so I'll just call it one full circle. So that's equal to 160 minus pi 3 squared, right? So this is going to be roughly 131.7 meters squared, right? So we're going to go ahead and jump to the next question. So once again, if you have any questions that you want us to do, send us a message. We'll be happy to work through them. So the next one is a grade 11 functions question. So it's financial application. So they're asking us in how many years will $600 grow to $1,000 if it's invested at 8% annually, compounded annually, right? So we need to know the equation for this. So if it's a compound interest, we're going to use principal times 1 plus my interest to the power of n. N is how many terms we're compounding, right? So n is the period of time that we're trying to find. Right? It's the number of years. So I is my interest. They've told us it's 8%. P is my principal, so how much we're investing initially, so that's $600. And A is my amount that's left after the compounding interest, so that is the $1,000. Right? So I'm going to replace the A with 1,000, my principal with 600, and my interest with 8%, so 0.08 to the power of n. Right. So for this we can divide both sides by 600 to try and isolate for the n. So I have 1.67 is equal to 1.08 to the power n. Right. Since this is a grade 11 question, we can't use logarithms yet. So that means we have to guess the number for n until we come up with the right answer. right? So we're going to try n is equal to 1, n is equal to 2, n is equal to 3, and so on, until we get close to 1.67. Right? So if we do n is equal to 1, we get 1.08 to the power of just 1, so that's 1.08. 1.08 to the power of 2, 1.08 to the power of 3, and so on. Right? This should give me the same thing, 1.08, this should give me 1.16, and eventually when I get to n is equal to 7, I should get 1.71, so that's close enough, so I'm going to stop there. Right, so my n is equal to 7, so that tells me that it takes 7 years for the $600 to grow to $1,000. So this is a grade 12 calculus and vectors question, so it's dealing with line intersections. So it's asking me to determine the intersection point of the line given to us as a parametric form and the plane given to us in the Cartesian form. Right. So what we could do is we could plug the x, y, z's into the Cartesian equation, meaning if x is equal to 4 plus t, I'm going to plug in 4 plus t into my x for my Cartesian equation. What's the purpose of that? So that I can have one equation with just one variable, which is my parameter, t, and solve for that t and see if I can come up with some value. If my t, if I can get a value for t, that tells me there's a point of intersection. Right, so then I can just plug that t back into the parametric form to figure out what those values are. So let's go ahead and do that. So x is equal to 4 plus t, y is equal to 1 plus 2t, z is equal to 5 plus 3t. Right, and my Cartesian equation is 5x, so I'm replacing x with my parametric equations. Right, so I'm going to plug in 4 plus t instead of my x. Plus 3y, I'm going to replace y with 1 plus 2t, plus 4z, z I'm replacing with 5 plus 3t. Right, the minus 20 is equal to 0. Right, so we have one equation with one variable, so we're going to try and isolate for t. Right, so we end up with 20 plus 5t, plus 3 plus 6t, plus 20 plus 12t minus 20 is equal to 0. Right. So when I collect the like terms, when I isolate for t, I end up with t is equal to -1. So that tells me there is a point of intersection, right? So what I'm going to do is just plug that back into the parametric equations. So my x was 4 plus t, so I'm going to replace t with the -1 to give me 4 minus 1 to give me 3, right? Y was 1 plus 2t, so 1 plus 2 times -1 is equal to -1. Z is equal to 5 plus 3t, right? T is -1 still, 5 plus 3 times -1 is equal to 2, right? So these are my points. 3, -1, and 2 is my point of intersection. Okay? So let's jump to the next one. So we're going to do two questions for this one. So this is a grade 11 or grade 12 trig identity question. So the first part is asking, give a counterexample to show that each equation is not an identity. We're just going to do part A. So part A is saying cos of x is equal to 1 over cos of x. They're asking me to prove that this is not true. It's not an identity, right? So what we could do is just plug in some value for x, right? If we say x, for example, is going to be pi over 3, right? If we plug this in to both the left side and the right side, and if we find that the left side is not equal to the right side, it's not an identity, right? So that's a simple example. So what we do is the left side is equal to cos x. So if we plug in pi over 3, cos of pi over 3 should give me 1 over 2. Right? Now if we do the right side, we did get 1 over cos x. So if we plug in 1 over cos of pi over 3, we end up with 1 over 2, which gives me 2. Right, so this is clearly the left side is not equal to the right side, so it's not an identity. Right, so we're going to do a trig identity question, so we're actually proving this identity. So again, we're going to do just part A. So we have cos squared theta minus sine squared theta over cos squared theta plus sine theta cos theta. All this is equal to 1 minus tan theta. Okay, so let's deal again. The common thing we're going to follow is for trig identities is we're going to tackle the more complex or the more complicated side. Right, so the left side is more complicated, so we'll try and simplify that and then deal with the easier one. Right, so the left side is cos squared theta minus sine squared theta with cos squared theta plus sine theta cos theta. Right, so immediately we should see that the numerator is a difference of squares. Right, this is a square, this is a square, and there's a difference of it. Right, so we could express that in factored form to say cos theta plus sine theta multiplied by cos theta minus sine theta. Right, all this is divided by the denominator, and from the denominator we should see that there's a common term in both of them, that there's cos theta in the first and the second term, so we can factor that out. So I'm going to factor out the cos theta to give me cos theta plus sine theta. Right, why did we do that? Because now we can cancel out common term on the numerator and the denominator. Right, so what are we left with? We're left with cos theta minus sine theta over cos theta. I've simplified the left hand side as much as I can. Right, so now let's deal with the easier side, which was the right side. So we had 1 minus tan theta. Right, another trick we should be doing every time we're dealing with trig identities is always convert the tan into sine and cos. It just makes our life easier to simplify and so on. Right, always break the ratios down into the primary trig ratios, or more specifically just sine and cos. Right, so I'm going to replace tan with sine and cos, so it's tan is equal to sine over cos. Right, and then I'm going to use common denominators to get rid of the 1, so I'm going to multiply the left side with cos, so I have cos theta over cos theta minus sine theta over cos theta. Right, this should give me cos theta minus sine theta all over cos theta. Right, now my left side is equal to the right side, so I proved my trig identity. Right, some common tips are that we should always try and simplify the more complicated side, bring it down to cos and sine as much as possible, and then deal with the simpler side and again try to reduce that to cos and sine. Right, we want as little term as much as we can. So this is a grade 10 math question, so we're dealing with centroids. So it's telling me a point C is the centroid of the triangle. So this is point C. Right, FGH is my triangle, and suppose H and M is 27 centimeters. So from this point to this point is 27. Find the length of H and C. So what we should know is that C breaks a median line into a 2:1 ratio. Right, what that means is this entire length H to M is broken down exactly in half. Oh, okay. Okay, so C breaks down a median into a 2:1 ratio. So we're going to let C, this is C, so we're going to let Cm is equal to X, That means HC is equal to 2x. Right? So if the entire thing is 27, so we can just say 2x plus x is equal to 27. So that tells me 3x is equal to 27, and then x, we can divide both sides by 3 to give me x is equal to 9. Right? So my HC was 2x. Right, it wasn't just x, so I can just plug in the 9 to tell me that my HC is 18. Okay, so for this, once again, we had to know that the centroid breaks down the median into a 2-to-1 ratio, so we figured that 27 is equal to x plus 2x. Right, so figured out what x is, and we know HC is 2x, so we plug that x in to find what that is. Okay. Okay. So we're doing a grade 10 trig question, so we're dealing with question number 6. So we asked to determine the length of the chord AB, so from this point, to the nearest tenth of the centimeter. And they've given us some information. They've told us this is 8.9. They told us this and this side are the same, so we also know this is 8.9. But they also told us this distance and this angle over here. Okay, so what we could do, I'm just going to redraw the triangles to show all the information given to us. This is 27.5. This is 15.5. We know this is 8.9, 8.9, so on. Right. So what we should do is we're trying to find this distance, right? This is A, this is B, so we'll call this distance x. We're trying to find x. So given this triangle, we don't have enough information to find x yet. We know this is 8.9, this is 8.9, but we don't have anything else. We don't have an angle, we don't have any of the angles, right? So let's try and find one of the angles. So we could, the best case is to find this angle over here, so we'll call this beta. So in order to find the angle, we need to find this one, right? Because angle in a line is 180, so if we find this one, we can find the other one. So that means we have to solve this triangle first, right? So if we know this is theta, this is 15.5, this is 27.5, and this is 8.9. Right, we can just use the sine law. So we know the sine of 27.5 over 8.9 should equal the sine of my theta over 15.5. Right. Then I'm just going to isolate for my theta, so it gives me sine inverse of sine 27.5 over 8.9 times 15.5. Right. This should give me roughly 54 degrees. So what we found is this angle right here. Right. So in this triangle we found this angle. So we know this is roughly 54 degrees. Right. So how can I find this angle? So I'm going to do 180 minus 54 to find what that is. So sorry, I've messed. This should be 54. It can't be 54 because it's a acute angle, right? So this is clearly an obtuse one, so I'm going to do 180 minus 54 to give me 126.4 degrees. Right. So then I can do 180 minus 124, which is the same as saying 54, right? Right. So if that is 54 degrees, then we can solve that triangle. So we know this is 8.9, we know this is 8.9, right? If this is 54, we can find what this length is. So this is x. So I can again use the sine law. I can say sine of 54 over 8.9 is equal to, we know these sides are the same, right? So we can find this angle easily. Can find what that is by just doing 180 minus 2 times 54, right? That should give me approximately 73 degrees. So I'm going to do sine of 73 degrees over x, right? And then x I can isolate for that, would be sine of 73 over sine of 54 times 8.9, which is going to end up being 10.6 meters. Okay, so that was a little messy. Let's go back and see what we did. So we're trying to find the distance AB, right, from here to here. So we're trying to essentially solve this triangle. We know this is an isosceles triangle because these sides are the same. This is 8.9 as well, but we don't have any other information. So we're going to use the triangle adjacent to that to get us that information, right? So we know this is 27.5 degrees. We know this is 15.5, and we know this is 8.9. So that's plenty of information to use the sine law to figure out what this angle is. Once we figure that angle, we can find the adjacent angle in the triangle that we're trying to solve, right? When we find that angle, it's a matter of using the sine law to figure out what the distance of x is. So let's jump to another question. So this is a grade 9 math question. We're dealing with area and perimeter. So we're asked to calculate the area and perimeter for this one. So we have a semicircle and a rectangle. So area would be the semicircle plus the rectangle, right? So the semicircle would be half of pi r squared, plus the rectangle is going to be just length times width. So what is my radius though, right? It's not evident, but we should see that the entire diameter is 4 centimeters, right? So to find the radius, we can just divide 4 by 2, right? So my radius ends up being 2 centimeters. So I can plug these values in, 1 over 2, pi times 2 squared. My width is 4, my length is 6, right? So then I end up with roughly 30.3 centimeter squared. Right. And then for my perimeter, I have 3 sides for my rectangle that I'm showing. So I have 4, 6, 6, 4 plus 6 plus 6, and I need the circumference of half a circle, right? The circumference of one full circle is 2 pi r. So the circumference of half, I'm going to divide it by 2. So 2 divided by 2 will give me just 1. And my radius I found earlier to be 2, so I'm just going to plug that in. Right, so this is going to give me 16 plus pi times 2, which is going to be roughly 22.3 centimeters. We're going to do one more question. So this is a grade 12 vectors question. So it's telling us if I, j, k are the standard unit basic vectors in 3D space, determine the values of this equation. Okay. So we know I, j, k, I is the vector in the x direction, j is the vector in the y direction, and k is the vector in the z direction, right? Each of them are orthogonal to each other, meaning each of them are perpendicular to each other. Okay, so that's going to be important in a second. So when we're dealing with dot products, we can distribute the vector inside. So we have the dot product of k and j minus 3k and the dot product of k itself, plus, again, since they're the dot product, we're going to expand this like a binomial, right? So we have I times dot product of I minus 4ki dot minus 4ki plus 4k squared, essentially, right? K dot k. Let me get rid of this. And then it's minus 8 times the cross product of I and k. So we'll start on this side, right? K dot j. So remember I said that each of these vectors are orthogonal to each other, right? So the dot product of two orthogonal vectors are going to be 0. Why? Because if I replace this with the magnitude equation, so I have k, j, and then it's going to be cos theta, right? What's cos of 90 degrees? It should be 0, right? So the magnitudes times 0 just gives me 0. So this entire expression evaluates to 0, right? And then the dot product of the vector itself is going to be just the magnitude. So it's going to be minus 3 times the magnitude of k. And we know all of these are unit vectors, so the magnitude should just be 1, right? We're going to do the same for I. The magnitude of I, again, is just 1 minus, now we have the dot product of two vectors again, k and I, right? The same rule applies here. If we take the dot product of two orthogonal vectors, it should evaluate to 0, so both these terms evaluate to 0, right? And then 4 squared is going to be 16 times the magnitude of k, minus, now this is the cross product, right? The cross product of I and k, I can evaluate to the magnitude of I, the magnitude of k, times the sine of the angle between them. The angle between them is 90, so that means the sine of 90 is just 1, so this evaluates to just 8 times the magnitudes of I and k, right? Once again, these are all unit vectors, so I can just evaluate the magnitudes to 1. So I have minus 3 plus 1 plus 16 minus 8. Okay, so this all evaluates to just 6. Okay, so that about does it for us today. So if you have any questions, send us a message. We'll be happy to help you out. So, hope this has been helpful. This has been T from AskZylor. Hope you have a good night.